A multiple of a number can be divided by that number without leaving a remainder. For example, the first 5 multiples of 4 are 4, 8, 12, 16 and 20. So basically, a multiple of a number is a number that's in that number's times table. So we need to answer true or false. 48 is a multiple of 3. To find out whether 48 is a multiple of 3, we can divide 48 by 3 and see if we get a remainder. Because remember, a multiple of a number can be divided by that number without leaving a remainder. So, using short division, 4 divided by 3 is 1 remainder 1, because 1 times 3 is 3, and we need 1 more to get to 4. And now 18 divided by 3 is 6, with no remainder. So, because we don't get a remainder, we know that it's true that 48 is a multiple of 3. Now, is 250 a multiple of 100? Well, if we divide 250 by 100, we get 2 remainder 50. 250 is not in the 100 times table, so it's not a multiple. Now, 365 is a multiple of 9. To find out whether that's true, we can divide 365 by 9. 3 is less than 9, so let's take the first 2 digits together. 36 divided by 9 is exactly 4 with no remainder. But now we have 5 divided by 9. That's 0 remainder 5. So, because we get a remainder at the end, we know that it's false. 365 is not a multiple of 9. Finally, 104 is a multiple of 8. To see whether that's true or false, we need to divide 104 by 8. 1 is less than 8. So if we take the first 2 digits together, 10 divided by 8 is 1 remainder 2, because 1 times 8 is 8, and we need 2 more to get to 10. And now 24 divided by 8 is 3, with no remainder. So because we don't get a remainder, we know that it is a multiple. So let's have a look at these questions in a bit more detail. First, we needed to work out whether 48 was a multiple of 3. We used short division and we didn't get a remainder, so we knew that it was true. So here we have 48, so 4 tens and 8 ones, and we can share these into 3 groups. First, we can share out 3 of our tens, and we have 1 10 in each group. Now, with this remaining 10, we can turn it into 10 ones, and that's why we write the remainder in front of the next digit. But now we can share out all 18 of those ones, so we don't have any leftover place value counters, we don't have a remainder, so we know that it's a multiple. The other way of thinking about multiples is to imagine counting up in that times table. If we counted up in 3s, eventually we would get to 48, so that's how we know it's true that 48 is a multiple of 3. And by dividing, we've shown that it's the 16th multiple of 3. If we count up in 3s, the 16th number that we say will be 48. Next, we had to work out whether 250 was a multiple of 100. But if we count up in hundreds, we have 100, 200, then 300. We don't have 250, so we know that it's not a multiple. Then we had to work out whether 365 was a multiple of 9. So we've got 3 hundreds, 6 tens, and 5 ones, and we can try to share these place value counters out between 9 groups. We can't share out our hundreds, so what we can do is exchange 100 counter for 10 10 counters. That gives us 36 tens, which we can share out with 4 tens in each group. But now we have 5 leftover ones, and we can't share out these ones because we have 9 groups but only 5 counters. So these 5 ones are our remainder, and that means that 365 is not a multiple of 9. If we counted up in 9s, we would go from 360 to 369. We wouldn't count 365, so we know that it's not a multiple of 9. Finally, we had 104 and had to work out whether it was a multiple of 8. So we have 104 ones, and we're sharing these counters out into 8 groups. First, we can exchange our 100 for 10 tens, and then we can share out 8 of those tens with 1 10 in each group. But now we have 2 remaining tens, but we can exchange those for 10 ones. So that gives us 24 ones, and we can share out all of those with 3 ones in each group. Now we don't have any place value counters left, so we've found that 104 is a multiple of 8. If we counted up in 8s, the 13th number that we said would be 104. So that's how we know that it's a multiple of 8.